Today we are going to learn about mastering GridSpec for dynamic subplots. We'll explore how to create and manipulate subplot grids with precision using GridSpec, enhancing your data visualization skills.
GridSpec is a powerful tool in Matplotlib that allows for the creation of flexible, dynamic subplot layouts. Unlike the traditional subplot function, GridSpec provides the ability to specify the position and size of subplots with precision, making it ideal for complex data visualizations. In this video, we'll delve into how you can leverage GridSpec to enhance your data visualization projects. Whether you're dealing with multi-layered datasets or require specific subplot arrangements, understanding GridSpec will enable you to customize your plots to meet your exact needs. We'll explore its capabilities, compare it with other tools, and set the stage for more advanced techniques.
To start using GridSpec, you first need to import the module from Matplotlib with the command from matplotlib.gridspec import GridSpec. Creating a GridSpec layout involves initializing a GridSpec instance with the desired number of rows and columns. For example, gs equals GridSpec 3 sets up a 3x3 grid. Each grid cell can then be assigned a subplot, allowing for flexible positioning. Use the add_subplot method to place your subplots precisely where you want them. For instance, ax1 equals plt.subplot gs02 places a subplot spanning the first row and two columns. This flexibility is what makes GridSpec superior to conventional subplot methods, as it allows you to combine multiple plots seamlessly. In this block, we'll walk through setting up a basic GridSpec layout and explore simple customizations to enhance your visualizations. When working with GridSpec, one of the most powerful features is the ability to adjust the dimensions and spacing of your subplots. This can be achieved by setting the width_ratios and height_ratios parameters in your GridSpec instance. For example, GridSpec 2 width_ratios equals 2, 1, height_ratios equals 1, 2, creates a grid where the first column is twice as wide as the second, and the second row is twice as tall as the first. Adjusting spacing between subplots is also essential for maintaining clarity in your design. The space and space parameters control the width and height of the space between subplots, respectively. By fine-tuning these settings, you can ensure that your plots are both visually appealing and easy to interpret. We'll demonstrate these techniques with practical code examples. For more complex visualization needs, GridSpec allows for nested grids, which can be particularly useful when dealing with intricate datasets or when you want to combine multiple visualizations into a cohesive layout. To create a nested GridSpec, you first define a primary GridSpec layout and then initialize additional GridSpec instances within a specific subplot area. For example, inner_gs equals GridSpec from subplot spec 3, subplot_spec equals outer_g0 creates a nested grid in the first subplot of the outer grid. This approach gives you the ability to create multi-layered plots, each with its own specific layout requirements. Throughout this segment, we'll explore the benefits of using nested grids and provide detailed code examples to guide you through the process. Subplot 2 Grid is another powerful tool in Matplotlib that allows you to place subplots in a grid using grid coordinates. When combined with GridSpec, you can achieve even greater control over your plot layouts. While GridSpec provides flexibility in defining grid dimensions, Subplot 2 Grid simplifies the placement of subplots by allowing you to specify their position directly with grid coordinates. For instance, plt.subplot2grid 3 equals 2 places a subplot at the top left corner of a 3x3 grid, spanning two columns. By integrating these two tools, you can create complex and highly customized subplot arrangements. This block will cover how to effectively combine GridSpec with Subplot 2 Grid and demonstrate its applications through practical examples.
Aspect ratios play a crucial role in ensuring that your visualizations remain consistent and interpretable. GridSpec allows you to manage aspect ratios by specifying the aspect parameter in your subplot definitions. The aspect ratio determines the relative height and width of a subplot, which can be critical when visualizing data with specific dimensional requirements. Adjusting the aspect ratio ensures that your plots do not become distorted, thereby maintaining the integrity of your data representation. For example, setting x.set_aspect equal ensures that the x and y axes have equal length units. In this section, we'll explore how to effectively manage aspect ratios using GridSpec and demonstrate its importance in maintaining the quality of your visualizations. In today's digital age, it's essential for visualizations to be adaptable to various screen sizes and resolutions. This is where implementing responsive design principles in your GridSpec layouts becomes invaluable. Responsive design involves creating plots that can dynamically adjust their size and arrangement based on the viewing context. This ensures that your visualizations remain clear and accessible, regardless of the device they are viewed on. Techniques such as using relative sizing and leveraging Matplotlib's figure size adjustments can help achieve this adaptability. By incorporating responsive design principles, you ensure that your data visualizations are versatile and user-friendly. This block will guide you through implementing these techniques with GridSpec, complete with detailed examples. The best way to solidify your understanding of GridSpec is to apply it to real-world datasets. In this block, We'll walk through several practical examples that demonstrate how to use GridSpec to visualize complex data. From financial data to scientific measurements, we'll explore how to set up your GridSpec layout to best represent your data. Each example will include step-by-step instructions, complete with code snippets and tips on improving your visualizations. By the end of this section, you'll have a solid understanding of how to creatively and effectively apply GridSpec to any dataset, enhancing both the interpretability and impact of your data visualizations. In conclusion, mastering GridSpec is a vital skill for anyone involved in data visualization. Its flexibility and precision make it an indispensable tool for creating dynamic and effective subplot arrangements. In this video, we've explored its core features, from setting up basic layouts to implementing complex and responsive designs. Remember, practice is key to mastering these skills, so I encourage you to apply what you've learned to your own projects. Your feedback is invaluable, so please share your thoughts and experiences. As you continue your learning journey, consider exploring our advanced Matplotlib features to further enhance your data visualization capabilities. Thank you for watching, and I look forward to seeing your creative implementations of GridSpec.